Question 6 of the higher level applied maths paper is a difference equations question, which is completely brand new to the course. It's new to the applied maths course, but isn't new to the proper maths course because it was there before Project Maths was the thing. So we're told that spider plants can reproduce asexually, producing new plants called spiderets or pups. This doesn't really matter. So we're just given this difference equation. We're told to find u2 and u3, but we're given u0. So u0 is 1 and u1 is 2. So u2 would be 2u1 plus 3u0, which is 2 by 2 plus 3 by 1, which is 4 plus 3, which is 7. u3 would then be 2u2 plus 3u1, which is 2 by u2 plus 3 by u1. It's 14 plus 6, which is 20. Now we're told to solve the difference equation for un. So the first thing we have to do is find the characteristic, which would be x squared minus 2x minus 3 is 0. Moving everything to one side. So we get that x is 3, or x is minus 1. So because these are two distinct roots, we have to use theorem 1, which means that the solution to our difference equation is going to be L times the first root to the power of n plus m times the second root to the power of n, just making sure to put the minus 1 in a bracket. Now we're told that, I'll just write down again, that u0 is 1 and u1 is 2. So we can do simultaneous equations. So we have that 1 is L times 3 to the 0 plus m times minus 1 to the 0. So that'd be anything to 0 is 1, so L plus m is 1. And that's going to be equation number 1. Secondly, we're told that 2 is L times 3 to the 1 plus m times minus 1 to the 1. So 3L minus m is going to be 2, and that's equation 2. So if we do L plus m is 1 here, and add them, well, the m's are going to go, and we're left with 4L is 3. So L is 3/4, and to get m here, it's just 1/4, because 3/4 plus 1/4 is 1. So therefore, right up here, un is L times the first root to the power of n plus m times the second root to the power of n. And that's our difference equation. Now to find u10, we just put 10 in wherever we see root n. So u10 is 3/4 times 3 to the power of 10 plus 1/4 times minus 1 to the power of 10, which I found out is 44,287, which is quite rapid. So now we have an inhomogeneous, non-homogeneous, something or other, inhomogeneous difference equation, where we're given that the solution is equal to minus 2 bracket n plus 2, which we can write as minus 2n minus 4. So the first thing we do in solving an inhomogeneous difference equation is to look at the right-hand side. Now the right-hand side would expand to minus 2n minus 4, which means that we approximate part of the solution as simply an plus b. So that means un plus 1 would be a times n plus 1 plus b, which is an plus a plus b, and un plus 2 is an plus 2 plus b, which is an plus 2a plus b. Now, we have to sub all these values into this, so it's actually going to be v instead of u. But anyways, we have that an plus 2a plus b, minus 2, because we're moving all the v's to one side, an plus a plus b, minus 3 times an plus b is minus 2n minus 4. Now, we're going to expand this out. So we have an plus 2a plus b, minus 2an minus 2a minus 2b, minus 3an minus 3b is minus 2n minus 4. Now, we're going to have to compare coefficients here. So we have an n here, an n here, an n here, is equal to n, and then the rest, a, b, which is b, to 4. So comparing the reds, we have an minus 2an minus 3an is minus 2n. So the n's are obviously going to go. So we have minus 4. N is minus 2, which means, or minus 4a rather. Minus 4a is minus 2, which gives a is 1/2. So now we can use this information in solving for the blues. So we have 2a plus b minus 2a minus 2b minus 3b is minus 4. So as a matter of fact, we don't actually need information from the a's because these are going to go. Now you have b minus 2b minus 3b, which we've found already as minus 4b is minus 4, so b is 1. That means solution A would be 1/2 n plus 1. Okay, now we go back to our normal regularly scheduled program with a characteristic, which we already solved, but I'll write again. X squared minus 2x minus 3 is 0, because x is 3 or x is 1, which we know already is theorem 1. So un is going to be L times 3 to the n plus m times minus 1 to the n. And that's going to be solution B. Now we have to add solution A and B together. Now I am running out of room here because I thought this wouldn't take up as much room. So I'll just move that down slightly because that's the last part of the question anyway. So we have to add A and B first. So this would be L times 3 to the n plus m times minus 1 to the n plus 1/2 n plus 1 is equal to Vn. Now we have to solve for our values. Now we're already given that u0 is 1, or v0 is 1, and v1 is 2. I think it's 1, v1 is 2. Okay. So the first one we have, well, v0 is 1, so L, or 1 is L times 3 to the 0 plus m times minus 1 to the 0 plus 1/2 of 0 plus 1. So L plus m is 0. Next one we have as 2 is L times 3 to the 1 plus m times minus 1 to the 1 plus 1/2 of 1 plus 1. So it'd be 3L minus m is be 3 halves take away, so that's 1/2, and that's equation 2. We have L plus m is 0. Add them, we get 4L is 1/2. So these obviously cancel. So that means that L is 1/8, which means that m is minus 1/8. So we get that L plus m is equal to 0. So you can finally write that Vn is L times the first root to the power of n plus m times the second root to the power of n plus 1/2 n plus 1. Now we have to calculate V10, which is 1/8 of 3 to the power of 10 minus 1/8 times minus 1 to the power of 10 plus 1/2 of 10 plus 1, which I've already calculated to be 7,387. Now, obviously you'd expect this number to be lower because we're actually taking out a population at the time. So if we let them all grow naturally without any sort of modifications to the population, it would grow rapidly. Whereas if we take them out, it's a much more controlled number, even if it's very large. So that is the solution to higher level applied maths question 6.